La Palma Island, evidence for a young Earth or an old Earth? Have you ever just looked at an object, let's say any geological formation on the Earth, and asked yourself, how old is that? Now, some things are easy, right? When I look at this streaming lava spewing out of the top of a mountain right here, I say, that's pretty young, right? That's today, that's right now. And this hill, this whole mountain right here, was formed by this plume of lava on La Palma Island. And I know that because I've watched this plume of lava over the last month and a half. And a month and a half ago, there's pictures, and this hill doesn't exist at that time. So I know that the oldest that that hill could be is, say, 45 days old. But then do you ask yourself now, when I pull back and I say, look, there's a house right here. And I ask, how old is this hillside? Like, how long has that hillside been right there as that hillside? Or what is the origin of the rock underneath it? How old is that particular rock? Well, I do have one clue, right? One simple clue, and that is if this house was built in 1950, well, I know this has been around for at least 70 years. I suspect then that this wasn't molten lava 70 years ago, or nobody would have built their house there. So it's going to take a little bit of time before you'd have the appropriate um, environment to be able to do that. But that's the question. How long has it been since this particular hill formed? After all, the Canary Islands are all volcanic in origin. This is underneath here is all volcanic rock. At one point, I presume that this hill was formed in the same way that these hills over here are being formed in the present as we see them. How old is La Palma Island? And how can we tell? Not only that, how old are the Canary Islands? Well, let's look at the Canary Islands real quick. La Palma is just one of 7 main islands of the Canary Islands. All are volcanic of origin. Nobody disputes that. Um, these islands are set in off the coast of Morocco, but the ocean is very deep. So it goes down to near 5,000 meters deep. That's these regions out here in the sort of the darker blue. And that means 5 kilometers of ocean. And then you have these very large mountains, right? 15,000-foot mountains coming off the bottom of the ocean and forming these islands, which are mountains above sea level. And some of those even rise up to, on Tenerife here, we have a mountain that's over 12,000 feet above sea level. So that's 12,000 feet plus another 14 or 15,000 feet below it. So these are enormous mountains that are all volcanic in nature. And of course, our interest is in La Palma, and specifically, we're interested in a spot right here, which is where the active volcano is. And we're going to use that volcano to ask the question, can we estimate how long it has taken to form La Palma Island? And then eventually ask the question, how long did it take to form all of these particular islands of the Canary Islands? So here we are with the current volcanic eruption is occurring right here. We have several lava fields that are forming, and some of them have reached all the way to the ocean. The volcano itself is well over 1,000 feet high up on the mountainside. And here you can see this is actually a nighttime shot of the lava streaming on down the mountainside at really quite a fast pace. And this is really an enormous amount of lava that's flowing. The river is very extensive, and you can see it fanning out into the ocean here. So this lava is creating, it's actually extending the size of La Palma Island. So from just this small snapshot, you can get an idea that the entire island was probably formed in a similar fashion, that you had volcanic eruptions that are then pouring out more lava, which then stream down the sides of these volcanoes into the ocean, and gradually the island grows over time. But how old are the islands? That's our question, right? Our question is, are the islands ancient, meaning tens of thousands, hundreds of thousands, potentially millions of years old? Or are they something less than 4,500 years old, as the young Earth creationist chronology of the world would suggest? Right? Those are two very different scenarios. So here's the conventional ages of the Canary Islands. So scenario one, an ancient Earth. In the conventional scenario, using radiometric dating methods, La Palma Island is 1.7 to 2 million years old. Now, obviously, I just showed you a picture of lava coming out of a volcano there. That's not 1.2 million years old or 1.7 million years old. We're saying is that the oldest elements or the oldest rocks found deep in that island are 1.7 to 2 million years old. And if you go to, say, Tenerife, 12 million years old, it also does have an active volcano on it that has been known to be active in recent historical periods. 11 million years old. You have an island down here that's 1.1. Grand Canary, 14 million years old, and then you get to these other ones that are even older. That's an important thing to note here later on is that this is a progressively older islands as you head farther west. The active islands, there's an active volcano here, and there are active volcanoes here historically. In historical records, most of these other islands have not had any volcanic activity except a small amount of volcanic activity right up here. All right, so those are the what we consider the conventional ages of these islands. And I would also note that if you were to visit these islands and you were to walk around, say, on this island here compared to walking around on this island, you would notice a difference between the two. You would say, this island looks all worn down. I don't see any volcanic vents. I don't see any cones anywhere because it's been so long since there was any volcanic activity that erosion has removed most of the evidence of that, other than the fact that all the rock and sediments is made of volcanic material. Whereas, as I'm going to show you, there are pictures of La Palma. It looks like, hey, there was been volcanoes that have been going on not too long ago here. Now, compare that to the young Earth ages for the Canary Islands. This is a pretty simple scenario. I just replaced the ages with the expected ages in a young Earth creationist timeline, and that would be less than 4,500 years old. Quite a contrast. Several million years old compared to 4,500 years old. So why 4,500? You may be scratching your head. You may be thinking, I thought that young Earth creationists thought that the world was 6,000 years old, or maybe potentially 10,000, but most of them now stick to that more strict 6,000-year-old age. So why not 6,000 years old? There's a very good reason for that. Noah's flood. Noah's flood is said to have occurred around 4,500 years ago, or potentially only 4,350 years ago. But I'll stick with the 4,500. And if Noah's flood is said to have resculpted the surface of the earth, and if it resculpted the surface of the earth, including generating these oceanic plates, right, that these islands are sitting on, then these islands formed after Noah's flood, or at least started at the very last stages of Noah's flood. And I can say that also because these islands consist completely of volcanic material. There's no sediment, there's no other like kinds of sedimentary rock that are on these islands that you would find, say, on other continents, which they would say was caused by Noah's flood. So if Noah's flood covered the entire world, it would have laid some sediment onto these islands had they been formed before the flood. So creationists would look at islands like this, as well as the Hawaiian Islands, and they would say, those are post-flood created geological formations. So that's why I'm saying 4,500. So they have to find the origin of these islands within 4,500 years. So now I'm going to quickly remind you that the islands you're looking at are just a small fraction of the actual volcanic material that has to be explained within that 4,500 year time frame. So as I was saying before, you have this deeper ocean area, but you see this lighter material here. That lighter material is not very deep. Some of it's only a few 100 feet deep, maybe to 1,000 feet deep. There are massive amounts of volcanic material in these areas, and all the way around, say, this whole complex. Essentially, there is several kilometers worth of volcanic material sitting on top of the Pacific or Atlantic Ocean plate. So you have the Atlantic Ocean plate, and then you have this volcanic material coming up through the plate, producing these volcanoes, which then grow these large mountains. And as they do so, much of that is spreading out over the bottom of the ocean floor. And then after a lot of that matter is there, then eventually it reaches the surface of the ocean and grows these mountains that are subaerial, meaning underneath the air instead of underneath the water. So all of this material has to be accounted for. La Palma stretches out. It has a huge fan of material here from what is thought to be massive landslides when the volcano got very tall and then slid down into the ocean. And so really the extent of this mountain covers this entire area. So young Earth creationists need to deposit all this material into a post-flood world. Now, how should we go about testing this idea of how long it's taken to form these islands? As I said, the conventional age dating of this would suggest that there are several million years of time to explain the origin of La Palma, and maybe 15 million years to explain the origin of this region over here. But young Earth creationists only have 4,500 years they have to squeeze these islands into. Hey, let's do some math. It's pretty simple math. All right, let's start out with some volume. There's 1 billion cubic meters in a cubic kilometer. So let's keep that in mind. In a cubic kilometer, so a kilometer on each side on a cube, a huge amount of mass, right? Contains 1 billion individual cubic meters. And then we can observe that the Palma volcano, which has been active for just under 2 months, has spewed an estimated almost 200 million cubic meters of lava already. So let's extrapolate. Let's say that this volcano continues its very prolific output of lava over the next 10 months, so for a full year. So we would say over a whole year then, that would amount to 1.2 cubic kilometers, right? Because 200 million cubic meters times 6 is 1,200 or 1.2 billion million. I can't get my numbers done. I said it was going to be simple math, didn't I? 1.2 billion cubic meters over a year. So that's 1.2 cubic kilometers when we do our conversion. So that means in 1 year, if this volcano continues at its current pace, it will add an entire cubic kilometer of new land, new material to this particular island. All right, now here comes the little bit of the tricky part. I've estimated that the La Palma Island volume itself of the entire island, that includes not just the space around that doesn't include just this part of land that you see above the surface, which goes all the way up to 2,000 meters above sea level. But that also includes all the mass that's out here around the island. So the almost 5 kilometers of rock underneath, of which much of it is, this is an entire block here that's probably 2 to 3 kilometers thick in that entire region. Right. So what did I do? I said that I think I said that if you took 30 kilometers by 30 kilometers, the current island around at sea level is 25 kilometers by about 35 kilometers. And I said, if you imagine that really you turn that whole thing into a cube, you'd have something like a 30 kilometers by 30 kilometers by maybe 6 kilometers high. And if you multiply that together, you get 5,400 cubic kilometers. So 5,400 cubic kilometers of material is what constitutes La Palma Island. You see what we're going to do? We've said how much lava is being produced by the current volcano. And we have figured out that that could produce a 1.2 cubic kilometers per year, but we have 5,400 cubic kilometers. So if we divide the 5,400 by the 1.2 cubic kilometers, what do you get? You get 4,500 years, 4,500 years. Amazing. This is what I got the very first time I calculated this. I didn't make the numbers all work out. I simply looked at the values that were given to me, and I estimated the amount of volume. I did the simple division and I got 4,500 years. So it would take just 4,500 years of continuous eruption at the current pace, those are the caveats, to create La Palma Island. It's a young Earth after all. That fits perfectly with the young Earth scenario. But you knew that was coming. We know volcanism has not been continuous, right? This is number one. Item number one. First reason that estimate isn't a very good one. We know volcanism hasn't been continuous. After all, if you'd gone to La Palma last year, there was no volcanism there, right? It's only been in the last 2 months. So now if we look back at records that the Spanish have kept over the last 500 years. Currently, we're looking at this volcanic eruption, right? In 2021. The previous one was 1971. There's one in 1949. Then you have to go all the way back to 1712 to find any volcanic activity. And they're only single years, meaning this volcanic activity didn't occur over long spaces of time. They were sometimes days, sometimes weeks, a couple times months, but never years. And then you have 1677, 1646, 1850, I'm sorry, 1585. And then if we go all the way back to 1470 and 1492 at the same location, just 22 years apart, you had two sets of volcanic activity. That roughly corresponds to around every 50 to 70 years or so, you have some kind of volcanic activity. The picture I'm showing you is what the top of the ridge of La Palma Island looks like at the top of the mountains. There's all these volcanic vents. Now, some of these vents are, I would say that the height of these mountains is about 300 to 700 feet, so they're not tiny. Um, and you can see differences between these, right? This one has what looks to be fairly fresh ash, whereas this one is covered with trees, right? And so there's a relative difference in age there that I think everybody can realize as a parent that this must have been more recent, right? This one was more recent, and this one is older. This one might have been about the same time because it kind of looks like this other one. I will tell you that all three of these are not known in history to have done anything. So they're not included in this list over here. So these are all older than 500 years old. So even this one that looks, I guess you could say, looks fresh is more than 500 years old. That should give you an indication. It takes a while for vegetation to come back and grow on the lava that's produced, right? The volcanic ash that's produced by these volcanoes. I'm particularly interested in these 500-year-old ones. Okay, so let's talk about these two that are from over 500 years ago. Here they are, and in this, by the way, this particular volcanic vent is only about 2 kilometers from the current volcanic eruption today, and that particular eruption has already produced more material than this one from 1470 and 1492. But notice this volcano spewed out lava, which then ran down a valley and then it ran down through what is a city now, except the city wasn't there at the time. Well, actually, there might have been a village there. And what's interesting about that is that you can still see the lava running through the city and people built on either side, but the fresh lava wasn't really worth building on. It's pretty obvious that's the case. There are farms on either side of this lava. That's 500-year-old lava. And yet, even today, plants aren't growing on that in any kind of efficient manner. So what does that tell you about the age of this particular vent? Got to be more than that, right? And in fact, this whole hillside is a lot older than 500. And then you get up into these mountains, which are eroded former volcanoes from some time, presumably much farther in the past. You see how we're pushing back now into 500 years ago, probably thousands of years ago, actually probably hundreds of thousands of years ago. But we'll wait to get to that. Right, interestingly. So here's what I realized from looking at, let's go back here. If you look at these particular historical events, so these are things that we have a record of, right? We have a human history, recorded events of these things happening. And then you ask yourself, how much material has erupted during that time over the past 500 years? The current volcano has, like I said before, if it occurs over the next year, we'll get 1 cubic kilometer. But right now, it's about 200 million cubic meters. Um, all of these eruptions combined only add up to about the amount of the current eruption. And our current eruption's only been going on for a month and a half. That's how impressive the current eruption is in terms of the volume that's coming out. So my original, you can see my original estimate where I just back calculate saying if it were to be continuous at today's level, it would only take 4,500 years to build the entire island. That pace has not kept up for 500 years. Nowhere near that. It seems to be an unusually high pace in the last month. So as I was saying, if you add all of this together, including 1470, 1492, which was this one right here, which is about the size of what we've got now in terms of production, I'm going to say all of that adds up to 2 cubic kilometers. All right, 2 cubic kilometers of material have been added to La Palma over the last 500 years. So we can take that number and let's use that number to extrapolate. 2 cubic kilometers, if that were to continue back for 1,000 years, would be 4 cubic kilometers. Now remember, we have to account for 5,400 cubic kilometers. So if I just divide 5,400 cubic kilometers by 4, the number of cubic kilometers per 1,000 years, I get 1,350 periods of 1,000 years, right? 1,530 1,000 year periods. So you just multiply the two together, and what do you get? 1.35 million years. So at the current pace over the last 500 years, in order to construct La Palma Island and all the material underneath what you visibly see, would take approximately 1.35 million years. Now look at the estimate, or look at the radiometric dates, 1.7 to 2 million. It wouldn't take too far, if this was 1.5 cubic kilometers over 500 years, this would be about 2 million years in order to make the entire island. So current day production is roughly equal to the radiometric dating value that we get for the age of the islands, rather than 4,500 years. 4,500 years requires continuous production of lava for all 4,500 years at this very high pace. Now, we know that pace hasn't occurred for the last 2,000 years, right? We know that, I'm saying 500 years here, but we know not for the 2,000 years because people have lived there for 2,000 years. People wouldn't have lived there if there was enormous amounts of volcanism. All right, back to, let's make the problem even more of a problem for young Earth creationists. All right, if it isn't already apparent that they have an issue, we're going to build several more problems onto this. Okay, that was La Palma. We said La Palma would take 4,500 years of continuous volcanic production. What if you had the same production of volcanic material happening on Tenerife, or this complex here, which is really one giant island or one giant mountain? This is more than double the size, or more than double the total volume of material. So that would be, you just have to double the 4,500, right? That'd be 9,000 or 10,000 years it would take at the rate of production that La Palma is experiencing today. And then if you go over here to these other islands, it's going to be even more than that because this is even a larger amount of mass. Then you have the problem of these islands, especially that one and this ferry over here, have been dormant for over 2,000 years, and actually likely dormant for tens of thousands, if not hundreds of thousands of years. But let's say, in fairness to considering the young Earth creationist viewpoint, what do we know? We know for 2,000 years nothing's happened there, and that's from historical records. Likely didn't happen much before that either, but in the young Earth model, it had to have happened somewhere then between 2,000 years ago and 4,500 years ago. So that's only a 2,500 year window to squeeze it in. So how fast must the volcanic material have been exuding from the Earth to produce these islands in just 2,500 years? a really, really high rate. All right, more than double, more like quadruple the rate that we're actually seeing occurring on La Palma Island. And that creates some new problems, right? The pace. You can say, oh, well, why not just have it, spewing all over the place? Okay, well, every one of these islands would have to be building all at the same time in the young Earth creationist model because they're all inhabited today. They've all been relatively quiet for the last 2,000 years. But we've got some other issues. All right, we've got what's called the sulfur dioxide problem. La Palma is estimated, the current La Palma volcanic eruption is estimated to be spewing 50,000 tons, that's metric tons, of sulfur dioxide gas per month. So if we say, hey, let's say that activity continues for 12 months, that's going to be 600,000 tons of sulfur dioxide gas per year. That sounds like an awful lot. It's on the balance of the whole Earth. It's not all that much, but nonetheless, at 1 year and one time in one place, that's a lot of sulfuric dioxide. Now, let's say in the young Earth creationist model, remember, they're going to have that kind of production to be over 4,500 years. That would be 2.7 billion tons of sulfuric dioxide gas. Now, as young Earth creationists are going to say, they're going to admit, of course, the volume has not been the same over 4,500 years old. It hasn't been consistent because we have historical records that show it's not consistent. Clearly for the last 500 years, but almost surely for the last 2,000 years, there's been very little activity here, very intermittent activity, in which case only a few million tons of sulfuric acid have been produced, not 2.7 billion. That only makes the problem worse, right? Because they're going to have to get all that lava produced sometime from the flood to, say, 2,000 years ago or 2,500 years ago. They're going to have to compress 32.7 billion tons of sulfuric dioxide gas production into just a couple thousand years. But it's much worse than that. That's one island. They're going to have to explain all 7 islands, which are on average about the size of La Palma. That would be 38 billion tons of sulfuric dioxide gas would have to be produced in just a time frame of a couple thousand years. I don't know about you, but even right now in Spain, when the wind blows the wrong direction, they're having to deal just a little bit with sulfuric dioxide and other things. They're getting ash and then some other things at very minor levels in Spain with today's volcano. But if you were to say you had 7 volcanoes going off at one time and they were all spewing 4 to 5 times as much per day as the current one is right now, you would not want to be living in Spain, right? For the last, from 2,000 years ago to 4,500 years ago, Spain would be a wasteland, toxic material, right? It'd be acid rain falling on you all day long at that rate of sulfuric dioxide production. Now, spread over 3 to 15 million years, it's really not a problem for the environment. But when you compress that all into a small space, it's a big problem. And the problem gets even bigger when you consider that this is just one island chain. This island chain is tiny compared to, say, the Hawaiian Islands, which would absolutely dwarf the Canary Islands in terms of total mass. And yet all of them, by young Earth creationist accounting, are also post-flood islands. And so also would have to be produced in a very rapid fashion. The problems with Hawaiian Islands are 10 times worse than I'm showing here. But the Madeira and Cape Verde island chains, which are to the north and to the south of the Canary Islands, their volume is about the same combined as the Canary Islands. So that would be another 37 billion. So you're looking at 75 billion tons of sulfuric dioxide gas being thrown into the atmosphere, or really during the early stages of this, right? They would be underneath the ocean because they wouldn't be at the surface yet. And so that would be being absorbed by the ocean, which then would make it very toxic to live in this part of the ocean. This is close to the entrance to the Mediterranean Sea, and so this would probably also contaminate the Mediterranean Sea with a lot of this sulfur dioxide, plus other different products that are produced when lava meets water. So the sulfur dioxide problem is a very serious problem for someone trying to compress the history of volcanic islands into very short spaces. All right, what are some other problems? What are some other interesting ways we could, I'd say, test, is this, does what makes more sense, an old Canary Islands or a very youthful Canary Islands? What about plant and animal colonization? A couple things to note here. 470 out of the 1,600 species that are native to the Canary Islands are endemic. Now, endemic means this is the only place where those 470 species live on the face of the earth, right? They're they're specially adapted to those particular islands. To be adapted to a place or be a different species, they would have had to evolve. They would have had to have changed from whatever something had to migrate there, right, from somewhere else. So probably from Morocco or Spain or one of these countries, something had to migrate to the island, then live on the island, grow to sufficient populations, have changes occur to them through natural selection and mutations and gene flow and so forth. And all that would have to accumulate into making 470 unique species. Those and 100 endemic animal species. So, like, they have their own kind of tortoise on the island. They have their own kinds of skink, and they have their own kinds of lizards and so forth that are there. So they would have had to have adapted and changed and become the unique species they are really before 2,000 years ago. Because when people first arrived and people described things and saw things, they already were unique at that time. All right. So that limits the amount of time that animals have to both migrate there, because it's not easy to migrate there, right? It's going to be accidental interchanges and flights getting there and being carried by a bird, like a burr on a bird to get a plant there. That's not a process that just occurs instantly. That itself takes thousands of years, probably tens of thousands of years, if not hundreds of thousands of years, to get a whole large collection of unique organisms over there and then have them change. But let's say, for the sake of the young Earth creationist argument, they're going to say, yes, the organisms had to colonize. And once they colonized, they had to adapt and change and speciate on that particular island so they would be endemic or unique to those particular islands. How much time would they have? Remember, the islands, you know, I'm saying that this all had to happen before 2,000 years ago. So they only have 2,500 years. Do you think these islands actually existed exactly when Noah debarked from the ark? No, the islands were still, I mean, you'd have to say that the whole island formed within years. Um, and even if it formed extremely rapidly or took hundreds of years, maybe at extraordinarily enormous rates of volcanism were occurring, and you built a 15,000-foot tall mountain underneath the ocean, and it finally peaks itself above the ocean, but you're still going to have to make a mountain that's 3 or 4 thousand or maybe even 10,000 feet higher above the ocean. How are you going to do that? You're going to have to keep spewing lava, right? And you're going to have it, and these mountains are created by explosive ashfall as well. If that's occurring at any high rate, what organism is going to migrate there and begin to live on an island which is incredibly volcanically active? So it's going to take time for it to grow a mountain underneath the sea. Then it's got to get above the ocean level, but it's still growing, in which case it's still not habitable. And then eventually it reaches a point where maybe volcanism slows down its pace enough that the lava can cool. But even so, most animals are not going to find it a friendly place to live. I showed you that lava that's 500 years old, and yet plants aren't growing on it yet. Let's say it takes 300 years for the soil to for the lava to break up enough that there's actual soil that plants can get a foothold in and begin to grow, and grow enough that it would be enticing for other animals, other insects first, and then eventually larger animals to get there. That process is minimally going to take several hundred years after the volcano ends its activity before you can start inhabiting any portion of that. And it requires colonization, lucky events, and eventually you might be able to colonize this area. This is squeezing everything into an extremely tight window, right? Maybe 1,000 years to make the islands. Then you've only got a couple hundred years in order to get it prepared so that organisms can live there. Nothing about these islands suggests that they're that young, that only if you were to go back just 3,000 years old, there was a naked island there with nothing on it. The first people that came there saw a very well colonized, they had a habitat in which that had various organisms growing in a complex ecology. That doesn't happen overnight. So all this, you put it together, this is a very problematic timeline for the young Earth creationist. Right? So let's put this together. No earlier than 4,500 years ago, new ocean crust was forming as the continents pulled apart. They have this rapid tectonic thing. Remember, Africa and Europe is separated from South America and North America, and young Earth creationists, most of them agree that those continents were connected, during the flood and then maybe immediately after. And some even think that plate tectonics didn't occur till after the flood sometime, in which case this continental, this ocean plate wasn't even available to sometime several hundred years after the flood to even begin to make volcanoes, right? That would be even worse scenario. But we'll just go with they immediately start making these volcanoes as soon as the flood is done at the very end. So Noah's stepping off the ark. These things are like boiling away over here, a couple thousand miles away. So volcanoes begin to appear, massive production of magma in multiple locations, right? Every one of these islands had to be being made at the same time. Now, the dating suggests they're not all the same age, that this is actually a progression, that one island formed, a hotspot underneath moved, and then it started forming another island, and then it's moved, and another island formed. So there's a progression of events, which then stretches the history out much farther, which is why it's thought that all the islands in total have taken about 15 to 20 million years to produce. La Palma just happens to be one of the youngest, which is why it's one of the most active. Once above the surface, volcanism had to continue to occur at a very high rate, preventing any meaningful colonization of the islands by life. And then volcanism had to be reduced to low levels, some level that's sort of similar to today. You would want to have a lot more activity than you have right now, this very day. Because honestly, if we had this volcanic activity that's occurring right now all year long, every year, eventually people wouldn't be living there, and most of the organisms living there would not persist over time. It's going to be a difficult environment. So the volcanism would have to be reduced to some low level for plants and animal communities to colonize it, develop. The organisms have to evolve into hundreds of new species prior even to humans migrating to the islands, because they migrated to the islands are like, hey, these organisms are different on this island than other places that we see. So that brings in your like hyper rapid speciation thing that young Earth creationists are promoting. And this would be one of the reasons they have to promote that, because they would have to see something like this and recognize that, look, you can't, you can't, you don't have a long time for these organisms to adapt to these places. So they must be able to adapt extraordinarily quickly in order for us to fit it into our 4,500 year timeline, which I would say is really more like a 500 to 1,000 year timeline at most for most of the things we're talking about. So in the end, La Palma Island, is it evidence for a young Earth or an old Earth? I think it's pretty clear that the La Palma Island is evidence for an old Earth. It's what the features we see on La Palma Island are the most consistent with an ancient developing island that has gone through a long series of events, allowing for the production of different islands that are at different ages and are, I guess you could say, they're at different stages of their life. The young Earth model requires essentially almost instantaneous creation of those islands over a very short period of time, in which case they really should all look very similar to each other, rather than one looking worn down and old like a stub of an island, kind of like the Hawaiian Islands. The newest Hawaiian Island looks like a fresh island because it has brand new volcanoes on it, whereas the other islands don't look like volcanoes because they're all worn down because volcanoes haven't happened for a long time there. They look like they are a progression or a series of ages. But in every young Earth model, there's no time for a progression. It all just has to happen right away because there's not even time for that. And so that's the best you can do, is say they just all were formed at the same time. This is just an example of look out your window, in my case, look at a live stream, watch this volcano, and you can watch a mountain forming. And it's impressive. And you're like amazed at like how much material has come out. And you're like, wow, I mean, that island is really, it's adding to that island. But when you start sitting down and doing the basic calculations, you realize that, oh, that's impressive. But nonetheless, it would take a long time to make those islands, a very long time to make those islands. And then when you get any sense of any nuance to it, right? Um, okay, it have to be consistent over time. So but it's not going to be consistent over time. If you just think about how volcanism works itself, there has to be storehouses basically of lava, blobs of lava deep down in the crust that are coming up to feed these volcanoes. There's a reason why the volcano isn't just consistently spewing forth lava 24/7 for hundreds and hundreds and hundreds of years. There are some rare exceptions of volcanoes that are active for long periods, but most sort of go through these belches, right? That's because it's a blob that's kind of coming up and then bloop comes out on the surface and then it has to recharge itself. It makes sense that there is this pattern. And the other thing I just remembered that I didn't show you in one of the previous pictures was is that if you look at La Palma, what you'll see is you'll see hundreds of cones. And those cones very obviously are from different age periods. And so they show a progression even on that particular island, including the end of the island where there's a massive volcano that sticks up some 6,000 feet above sea level. And that particular mountain itself even blew its top at one time and slid off down into the ocean, probably creating some kind of tsunami way, way, way in the past. Um, and so the island itself is just, you walk around there and you would see a series of historical events which are spread across a long stretch of time. And that's just accounting for what you see above the surface of the land, above the surface of the ocean, not the 85 to 90% of the mass of La Palma, which is all underneath the ocean, which also has to have its own history as well. Okay, that's the question. Old Earth, young Earth. There's a compelling case for saying that the world is very old. Again, my name's Joel Duff. I don't think I said that before, but I'm glad you joined me if you've made it this far. And I want to tell you that I blog at thenaturalhistorian.com. And if you enjoyed this video, I'll be making a lot more videos of interesting science stories, talking about science and faith issues, and maybe just exploring some interesting molecular biology as we go along. And if you would like to hear any of those things or be informed of them, you could hit the subscribe button. All right, that's it for me. Thanks for listening. Bye bye.